So to end this chapter, let's talk about rationalizing a denominator if it is an expression such as this. So a sum or difference, more than one term. Right, over here we learned to multiply by whatever it takes to make the bottom an integer. Over here, right, if I were to multiply this by root 2 over root 2, I would get root 2 over root 2 times 1 plus root 2 times root 2, and I'd still end up with roots in the denominator. So what do I do? What I'm going to rely on, actually, is the fact that if I have a plus b, and I multiply by a minus b, I will have no, right, I'll end up with both of those terms squared, which will take care of roots no matter where they are. Maybe I have two roots. Right, what would I do with that? Well, I can multiply by what is called the conjugate radical. So if they're being added, as in this situation, what I'll do is I'll multiply by 1 minus root 2. Well, it could be root 2 minus 1, but I'll keep the same order here. And that is legal because I'm going to multiply by the same thing on the top. So I'm multiplying again by 1. I'm not changing my expression, just turning it into a form that I prefer. Alright, so let's go ahead and multiply that out. So on the top I'll have just 1 minus root 2 times 1. And on the bottom, if you want to put those in parentheses, I have 1 times 1 minus root 2 plus root 2, just showing you how it cancels out. Right, you could skip straight to that, that's fine. Minus root 2 times root 2, which is 2. Alright, so 1 minus root 2 on the top is going to stay. Those cancel out. I have 1 minus 2, which is negative 1. And anytime you got negative 1, you can simplify by taking negative 1 out of the other half. Right, if I take out negative, it's negative, right, here's negative root 2, and here's my positive 1. Or you'll begin to recognize I can flip the order and take the negative out. Right. Kind of like 3 minus 2 and 2 minus 3 are opposites, 1 and minus 1. If I exchange the order, I'm finding the difference, but in the other direction. So this simplifies down to root 2 minus 1, because those two cancel out. So you can do that to rationalize a denominator when it looks like this, or a numerator. If it were in the top and you wanted to change that, for example, if you had root 2 minus 1 in the top over 5, and you did not want roots in the numerator, then multiply by root 2 plus 1 over root 2 plus 1. You'd end up with a squared, which is 2, minus b squared, which is 1, which simplifies to 1 over, and over here you have 5 root 2 plus 5.